So today we are going to continue discuss the ER design exercise for the real estate database. I actually upload the data description to the Blackboard already under the lessons plan. And I think I'm going to also discuss another ER design problem, so that with these two in-class exercise, I hope that you feel more comfortable in your assignment number 2. So I think if we have some time left for today, I'm also going to discuss the assignment number 2. So if we cannot finish everything today, then I think we will take some time, at least half of the class time next week, next Tuesday, to wrap up the ER design. So I think the last class we pretty much end up here. Let me see if I'm able to get a little bit bigger now. Yeah, I think you should be able to see it. Okay, so I think in the last class, I think the only 2 attributes we didn't draw in the ER diagram are actually from the last bullet or sentence. So if a property is sold, the database should record the sale price and the date. So I think there are 2 types of design. So one type of design is that we are going to represent sale price and the sale date as an attribute of the property. Okay, so I think there's a problem for doing this is that if some property stay unsold, maybe later never be sold, although the owner want to sell it, then we will not have values for the sale price and sale date. But I think that's okay. So this is one design. The second design, I think you can model this sale price and the sale date as a relationship type. So instead of putting sale price and the sale date as attributes of the property entity type, we actually model this kind of more like event as a relationship between sales office and property. So this relationship is called sold, and then this sold will carry 2 attributes, one for the sale price, another one for the sale date. Okay, so that's kind of the second design. I think both design, if you convert them into relation schemas, I think both will be pretty much the same. So then whichever you prefer, I think that's fine. Maybe you'll prefer the first one because it's kind of more straightforward and simple. And you just simply put attributes, those 2 attributes at the property. Okay, so now I think we kind of sketch out the entity types along with all relationship types according to the data description. Next step, we're going to pretty much specify the constraint for each relationship type and also make any assumptions that if there's a need. Okay, so first let's start with has relationship between sales office and employee. So according to the data description, like each sales office is assigned 1 or more employees. So this pretty much shows tell you that a sales office has probably minimum 1 employee and may have multiple employees. So give you an idea about the minimum value and the maximum value for the relationship, for the number of relationship instance the sales office may participate in. So I think in the past, in the previous example, we in the class we mainly focus on the coordinator ratios and the participation constraints. So today, I think I would like to show you for the using the minimum maximum notation. So if you're familiar with, let me try to find the text box. So if you're familiar with, sorry, I have to familiar with UML, so I think those notation, minimum maximum notation is pretty similar, except location you put the minimum maximum. Okay, so now I got it. So according to the data description, a sales office can have one employee or between 1 to more. So the minimum number is 1 and the maximum number is multiple. We use small n to represent. So we supply this pair of numbers on the sales office side. So again, so the first number indicate the minimum number of relationship instance the sales and sales office can participate in. So the minimum number can have only 2 options, 1 or 0. Okay, 0 means that an entity may not participate in that relationship. 1 means that each entity must participate in the relationship. So this 1M pretty much means that a sales office must participate at least one relationship instance. This has relationship instance means that it must have at least one employee, and it may participate multiple relationship instance. So that the semantics through this has means that the sales office may have multiple employees working on it. Okay, then let's look at the minimum maximum for the employee. So let's go back to the okay, no, I think it's bad. Okay, then I think then this sentence like an employee must be assigned to only one sales office. So that means that an employee can work for only one sales office. And I think that's one indicate both minimum and maximum. Okay, so that's why this the minimum maximum notation for the employee will be 1 1. So this 1 1 indicate minimum maximum both is 1. So that means that an employee works one and only one works for one and only one sales office. Okay, questions? Okay, now let's say the is managed by relationship between the sales office and employee. So this relationship pretty much given a sales office, it identifies the employee who is the manager of that sales office. So here I think for each sales office, there's always one employee assigned to manage that office. An employee may manage only the sales office to which he or she is assigned. So I think this whole paragraph pretty much can help us to determine the the minimum maximum notation for these managers on the employee side. So an employee can manage only one sales office, right? And this sales office must be the one he or she is working for. So in this case, the minimum maximum pair for the employee will be 1 1 again. So this 1 1 means that an employee is managed by one and an employee manages one and only one sales office. Okay. And then regarding to the number, I'm sorry, I think I'm wrong here. Sorry, I think my mind is not clear. Sorry for that. I'm having this pretty bad cold. So I think minimum should be 0. Okay, so I think the first one, there's one employee assigned to manage that office. So that's actually regarding to the minimum and the maximum for the minimum maximum pair on the sales office side. So but let's first discuss the employee participation. So some employees, if they are manager, they are going to participate this managed by relationship for some employees, if they are not a manager, then they will not participate in this managed by relationship type. So that's why the minimum will be 0. So 0 means that some employee will not participate. Okay, maximum is 1, indicate if an employee participate in this relationship, then an employee can be related to only one sales office. So that indicate an employee can be a manager of only one sales office. Okay, so that's kind of the second sentence here. An employee may manage only the sales office to which he or she is assigned. Since an employee can be only assigned to one sales office, that means that if an employee is a manager, he or she can only manage his own department. Then regarding to the, let me see if I'm able to do the copy paste here. So regarding to the sales office, so what's the minimum? So minimum means that if the minimum relationship instance, this is managed by, that a sales office can participate. Since each sales office, there's always one employee assigned to manage that office. So that means that at least the sales office will have at least one employee as a manager. And also there's always one. So I think according to this sentence, we can infer that the department can have one and only one manager that manage that. So that's why the minimum and the maximum both are 1. So minimum 1 means every sales office must participate in the managed by relationship. Okay, maximum 1 means that every sales office can be managed by only one employee. Okay, questions? Okay, so feel free to ask questions. So let's go to the list. So let's try to find the list. So the form list property for sale. Let's see. And each unit of property must be listed with one and only one sales office. So means that given a property can participate in this list relationship only once. Okay, because sometimes a property may be jointly listed by multiple sales office, but according to this database, their business rule is that each unit of property must be listed with one and only one sales office. So let me copy paste. Sorry. Okay, so I think for this properties, minimum maximum notation will be 1 and 1. So the first one indicates the minimum number of this relationship that a property can participate. I think this minimum number of relationship instance actually can be interpreted as the minimum number of sales offices that will list that property. So that will be 1. Okay. So why 1? So I think here it said our property must be listed. So that means our property must be participating in this relationship. The maximum 1 indicates that a property can be listed at most by one sales office. So that's kind of this sentence indicating too. So each unit of property must be listed with one and only one sales office. So this one, only one, indicate 1, 1. Minimum is 1, maximum is 1. Okay. So then for the, sorry. Okay, then for the sales office participation. minimum maximum notation, not participation, sorry. So let's see. A sales office may have any number of properties listed or may have no property listed. So that actually means that if a sales office have no property listed, that means that sales office will not participate in this list relationship tab. That indicates the minimum number of the relationship instance that participate by a sales office will be 0 when that sales office does not list any properties. And also office can list multiple, any number, that means multiple properties. So the maximum number will be n, small n. So this n indicate multiple. So this 0n really saying that a sales office may not list any property, so or may list multiple properties. So that's why minimum is 0 and the maximum is n. Okay. Then let's move on to the owned by, so between the property and owner. So each unit of property has one or more owners. Okay. So I think a property must have an owner. So usually, so that means that each unit of property has one or more owners. So it means the minimum number will be 1, means at least one owner. If it has more owners, then the maximum number will be n. Okay? So that's the minimum maximum notation to describe the property's participation through this owned by relationship. And then the owner side, okay? An owner may own one or more units of property. So I think that's basically means that an owner, the minimum property an owner may own will be the 1 and the maximum will be n. Okay, so that's kind of how we use this minimum maximum notation to representing the relationship constraints. So any questions? I think for this one, this data description gave pretty detailed information about the database. So that's why we are able to infer the information to specify the minimum maximum notation. So that's why I think according to our design process, we didn't make any assumption. Okay, so that's why in this case, we don't have any assumption. But this is very rare because usually when user write their data description, they didn't write in terms of the designer's view. So usually you will miss a lot of information in the design, so you have to make assumption. But for this one, I think real estate database, the data description is pretty comprehensive. So that's why we do not need to make assumptions in order to clearly specify the minimum maximum notation for each relationship type. Okay, so questions so far? So I use minimum maximum notation. I don't know, do you understand? Or you prefer the coordinate ratios and the participation constraint? So you just let me know. So I think either way will be fine. So as long as you can understand and specify the relationship constraints by either one of the notation, you're good. Okay, either minimum maximum or the participation constraint. Let me probably show you if we design using maximum coordinate ratios and participation constraint. So what it looks like. So for the coordinate ratios, we actually instead of provide a pair of values on each side of the relationship tab, we actually put a single number on each side. For example, the number on the employee side actually describe that given, on the sales office, on the sales office side, this number describe that for an entity, employee entity, what's the maximum number of the relationship instance that employee can participate. So since an employee can be working for only one sales office, so then the number here will be probably, we can give the comparison. So I put it here using the 1. So let me using a different color. So okay. So this one, this coordinate ratio. So this one describe that given an employee, that employee can work for maximum one sales office. Okay. Then the number on the employee side. So this number actually indicates that given a sales office, how many relationship instance this has relationship instance that sales office participate. So this has relationship instance can be interpreted as a sales office has related to one of its own employee. So since a sales office can have multiple employees working for it, so that's why this number will be the capital N, indicate multiple. So it means that a sales office has multiple employees. Okay, and this 1 means that an employee is assigned or working for only one sales office. So similarly, we can also put the coordinate ratios for managed by. So if we put 1 on the sales office side, so this one used to interpret given an employee what how many relationship instance that employee will participate. So this is managed by relationship type. So because an employee can manage only one department, so that's we put 1 here. So coordinate number for the employee will be 1. Then the number on the employee side, this number actually describes the, sorry, I just try to make sure it's distinguished a little bit. Okay. So this one on the employee side, that's actually describe the sales office participation. Okay. So we put 1 here means that each sales office can maximally participate this managed by relationship only, maximally once. And this relationship instance used to relate the sales office with its own manager. So we have 1-to-1 for the is managed by, and we have 1-to-many for the has relationship. Then for the list, I think the same thing. So we put a number. For example, if we put a number on the property side, so that's actually this number used to describe kind of maximum number of the list relationship instance a sales office can participate in. So this maximum number can be translated into the maximum number of the properties a sales office list. So that will be N, because the sales office can list multiple property. Okay, then the number on the sales office side used to describe that given a property, the maximum number of the relationship instance a property can participate in. Again, this maximum number can be interpreted that the maximum number of the sales office can list a property, given a property. Then this is 1, because according to the data description, a property can be listed by only one sales office. Then for the owned by, the same, we put 2 numbers. So let's first put a number on the property side, this side. So that's used to describe that given an owner, how many relationship instance, this owned by relationship instance, an owner can participate in. Since an owner can what? Can own multiple properties. So that means that an owner must participate in multiple owned by relationship instance. So 1 instance for each property a owner owned. Okay, so that's why we put n on the left side of owned by. Then here, this number on the right side of the on the owner side. So this number actually used to describe that given a property, how many relationship instance, this owned by relationship instance, a property can participate in. So it can be translated that given a property, how many owners will be related to that property or owned that property. So according to the data description, a property can have multiple owners. So that's why we record this %. So it really can describe the share of each owner on the specific property. So this side should be also n, right? But usually we do not use 2 n's in one coordinate ratios. So we're going to replace 1n to m. I think just for the, just try to use 2n. Presenting the same thing, multiple. Okay, so that's the coordinate ratios. Sorry, I think there's some connection issues here. So, okay, now for the participation constraints, that's the same. So participation constraint actually indicates the minimal relationship instance. So for the sales office, for the house has relationship tab. So sales office must have some employee working for it. So that's why its participation will be total. So that's we need to where's my, I always cannot find, where's my shape? Okay, sorry. Okay, so that's kind of a this double line is too. Okay, so this double line indicate that the sales office participation is total. Okay, then for the employee side, since every employee must work for a sales office, so that's why its participation is also total. So another thing you can tell if it's total partial, if you have let me see if I'm able to do the where's my setting? I haven't used this one for a long time. It's not allow me to do the settings. Okay, so yeah, I forgot about that. So this one, so that will be the double line. Come on. It's so awkward to do this one. Okay, let me. Anyway, so that means the total participation. So if you know the minimum maximum notation, then if the minimum is 0, partial participation. If the minimum notation is 1, that's indicate total participation. Okay, good. So so how do we know the double line or single line? Double line means total participation. So total participation basically means that every entity, for example, if you look at the employee, every entity in the employee entity tab will participate in this has relationship. So that requires that if every employee participate has, that means that every employee must work for a sales office. Yeah, that's indicate total. Partial, basically we use single line. So this total participation, partial participation, that's notation actually consistent with minimum kind of when we have this minimum maximum pair, it's kind of equals to minimum number. So that minimum number indicate the minimum number of the relationship instance that an entity can participate. If it is equals to 0, like this one, that means that the employee's participation is partial. Why? Because not all employees participate in this managed by. Only part of the employees who are manager will participate in the managed by. So in this case, for the managed by relationship, employees' participation is partial. And for the sales office, that's a different story because each sales office must be managed by an employee. So that indicates every sales office must participate this managed by relationship so that we can relate the sales office with its manager. So then the sales office participation for the is managed by relationship will be the total. So that's why we're going to put the double line here. Okay. Sorry for the bad drawing, but I just want to the double line, okay? Okay, so then for the list, okay? So according to the data description, a sales office may not have any property listed. So that means that the minimum number of the relationship instance a sales office participate will be 0. So that's why we keep the single line here, means the sales office participation is partial. But partial means that some sales office will participate to list their property. Some sales office does not participate. That means that they don't have any property listed. Okay, so this is partial. For the property's participation, so every property must be listed by a sales office. So that's why all property have to be related. I mean, every single property has to be related to a sales office. So that indicate the property's participation will be total. So we have to use double line. Sorry, I have to use this double line indicate. The property's participation is total. Okay. Then for owned by. So owned by, so each property must be owned by one or more owner. So that means that every property must participate this owned by relationship to relate its owner. So that's why the property's participation here will be total, double, okay? Then the owner's participation. So every owner must own one or more properties. So that indicates every owner must participate this owned by, okay? So that's why the owner's participation will be the total, okay? So this total means that owner, sorry. Owner must participate in the owned by to in order to relate to a property. Okay, so any questions? So for this one, when we use coordinate ratio, we do not need the minimum maximum notation. So that's kind of a, that's kind of things we want to remove. Okay, so if we use coordinate ratios plus participation constraint, we actually should not use minimum maximum notation because the two means the same thing. So that's why you only pick one notation, either minimum maximum plus minimum maximum or coordinate ratios plus participation constraints. So any questions? Okay, good. So if you do not have any questions, then I think that's pretty much the solution for the real estate. So I think that maybe the hardest part is to determine the relationship constraints. So that's why, and also identify the relationship type. So that's why I think I'm going to show you another ER design problem so that we can work together, and hopefully you can kind of, and we will review everything. So hopefully you understand better. Okay. Any questions regarding this real estate database? Okay, if no, let me save it. Then let me close this one. And then we move on to the university database. So as I think we discussed in the previous example, for our database design, if we do the ER modeling, our first step is trying to identify the entity types. So I think it's easy to identify the entity types. Then once we identify the entity types, then we can further investigate the relationship types among them. Okay, so let's read this data description. So the first bullet, the university keeps track of each student's name, student number, social security, current address and phone, birth date, sex, class, like the freshman, sophomore, and so on, major department, minor department, if any, and degree program. Okay. Some users' application need to refer to the city, state, zip of the student address and to the student's last name. So both social security number and student number have unique values for each student. So at least I think when we read this this kind of paragraph, we probably can infer that we need to model student as an entity type. Why? Because it lists so many attributes to describe a student. So that's why we should put the student as an entity type. Okay. And also some kind of information, like for example, give you birthday, sex, and the class. So parentheses, freshman, sophomore, and graduate. So the class is supposed to be the attributes to describe a student. And then the freshman, sophomore, and graduate, that actually consider the domain of the class. So by domain, I mean possible values a class may take, okay? A class attribute may take. However, in the ER design, we only model attributes. We do not need to model any domain or values, possible values of an attribute. So that you need to be aware of that. So that's why in your design, we have ovals to indicate attributes. So we have class as an attribute. That's it. We do not need to record any information about possible values a class can take. So that's maybe related to the implementation part. And another one is that some users' application need to refer to the city, state, and the zip of the student address. So that's also indicate like a requirement that when we record student address, we may want to also record the city, state, and the zip of the address. So there are two ways that you can model it. I think maybe according to the data description, maybe the way we want to use is that we put the current address as a composite attribute. So then we also model its component, okay, for the composite attribute, okay? Then each department is described by name, department code, office number, office phone, and college. So once again, since this department carries several attributes, so then we need to model department as an entity type, okay? And also both name and code have unique values for each department. So this also indicates that name is a key for the department and department code is also a key. So since we have two keys, then we have freedom to underline only one of them. So whichever we underlined will be the primary key. I think for the student, that's the same thing. So social security number and student number both have unique values. That means that for the student, we have two keys, okay? Then the third one, each course has a course name, description, course number, number of semester hours, level, and offering department. So once again, this course has several attributes. That means we can model course as an entity type. And also the value of course number is unique for each course. So that's usually indicate the course number is a key for the course entity type. Each section has an instructor, semester, year, course, and section number. So again, this section has several attributes. So we may want to model it as entity type, okay? And the section number distinguish different sections of the same course that are taught during the same semester year. So its value are 1, 2, 3 up to the number of sections taught during each semester. So this actually describes that given the section number, the section will be numbered as 1, 2, 3 to whatever number of the sections are offered for a course, okay? So this may indicate that since we need to record session and we have for each course, the first session will be always valued as session 1. So that indicates we may have multiple sessions have the same section value or section number. However, those sections should be belong to different course, okay? Then a final grade report has a student section, letter grade, and a numerical grade. So in this case, I think we can model the grade report as an entity type. But later, I think we can refine to a relationship. I think the trick here is that a grade report has a student, a section. So if you recall that we have a student entity type, we have a section entity type. So this grade report is talking about student, kind of relationship between a student and a section, and also record the grade for that particular student on that section. So this kind of when the grade report has attribute student and the section, and both student and the section are also modeled as entity types, that gave us a hint that we may need to model grade report as a relationship between student and section instead of as a separate entity type. Okay, but anyway, it needs the experience, so that's why I just want to show you the different way we can model a concept, either by entity type or by relationship type. Okay, so we're going to discuss that later. So that's pretty much the rough analysis of this data description. And then I think we are pretty much identify the 4 entity types. Okay, actually 5 in the first round. So again, the design, ER design is considered an iterative process. So it may take several turns before we finally finalize our design. Okay, so that's kind of the thing you need to be aware of, that usually we won't be able to design a ER diagram in one round. We may need multiple rounds, multiple revision, then to make the designs, more accurate and concise. Okay. So I'm sorry. So maybe so I think I post this university database description on Blackboard. So I think you're able to. Let me see. Okay. I'm trying to. Sorry. Okay, so this is pretty much the best I can show. The first step of the ER design, identify entity types. Okay, so I think for the student, we model the current address as what? As a composite attribute. Okay, so I think what else? No. Okay, then I think you shouldn't have any problem with these 5 entity types identified in the beginning. The next step, we need to identify the relationship type. So relationship type can be either inferred from the data description, or can be, I think there are 2 ways. One is to directly infer from the data description. The second way is that we're looking for attributes in an entity type. That attribute has same semantic as some entity type. Okay, so if we can identify an attribute and an entity type, both referring to the same real-world concept or things, then we consider there's a relationship between the entity type of the attributes and the entity type that identical to the attributes. So let's see the example here. I think, okay, so I think when we're talking about major and minor, so according to the data description, so hard for me to move. Okay, so when we're talking about the data description, so this major department, minor department. Okay, so that means that both major and minor means department. Okay, then we know that if major refers to a department and the minor refers to a department, then we can refine this major into a relationship type. Okay, and I think this is kind of one how we identify the relationship type. Another one through the attributes is that, let me see, for example, the course. So course, we have offering department. So offering department is a department. So then this offering department as an attribute has the same semantics as department entity type. So we have one attribute, one entity type, both representing the same thing. So that really indicates we can refine this offering department into a relationship between the course where offering department belongs to and department entity type. Okay, so by refine, I mean that once we create a relationship type between the, where's my diamond? Yeah. For example, once we describe refine the offering department into a relationship tab, then we can cross out offering department, okay? And tab anything here. So I'll do the offers. Okay, so that's what I mean, how we can identify the relationship tab between anti-tabs. So we're looking for the attributes and the anti-tab. That's referring to the same semantics. Okay, so once we refine this offering department to offers relationship tab, then offering department no longer needed. Why? Because this offering department really describes which department offers the course. Then since we have this relationship, then given the course, through this offers relationship, we are able to identify or find the offering department. So that's why it's considered redundant. We can remove it, okay? And I think, okay, for example, yeah, in the section anti-tab, we have course attributes. So course attribute and the course anti-tab that indicate we can model this course attribute by a relationship tab between the section where the course belongs to and course anti-tab. Okay. For example, I do the belongs to. How about belongs to? Maybe make it smaller. Okay, so that belongs to. So once we have this belongs to between the section and course, then we can remove the course number that's considered a course attribute from section that's considered redundant. And I think probably before we can also do the same thing for that minor and the major. Sorry. Okay. Cannot be lazy. Just let me draw another one. Outline. Okay. Then for the major, we can write a name like major in, a student major in a department. And that's the then another one representing minor in. Let me see if you're able to see clearly. Yeah. Then we connect them together. So in this case, between student and department, there are two relationship types. One to describe which department a student major in, the other one to describe which department a student minor in, okay? And then we can, because we refine the major minor into a relationship type, that's why we're going to cross out minor and the majoring from the student entity tab. I think the last one about this grade report, okay? So if we follow the same strategy, grade report has a student. So that means we don't have a relationship tab between grade report and student, okay? And then we also have section. So that means that we also need to create a relationship between the section and grade report, okay? So that's maybe your initial design. So then you can tell that this kind of form section through a relationship to the grade report and the grade report through a relationship to the student. Now, according to the design principle, we have to cross out student and section. Then the grade report only has letter grade. So that's really make grade report kind of not a good anti-type, because letter grade, numerical grade can be repeating for so many different students. And also, when we remove student and the student section from the grade report, now it's pretty hard to put them together. Why do I say so? Because if we model the relationship like this one, then a student relate to a grade report. Without student, without section information, we only have, we only have the grades here. And student. I'm sorry. I think kind of the connection is broke. Yes. Thank you. Welcome back. So let me repeat again. So if we refine this grade report and into, kind of based on the student and the section attributes of the grade report, we model them into two separate relationships. Then through these two separate relationships, it's so hard to connect a grade report with a specific student for a specific class. Why do I say so? Because through this relationship, we can only relate a student with letter grades, okay, without any section information. Then through this relationship, we can offer section, we can relate a section with a grade, but without student, okay. So this basically means that even we trying to connecting the student info with section info through this grade report, it might not be always guaranteed. Why? Because when we relate grade with the section and we have grades info, we have no idea whose grade it is, especially if a section has so many students. Then giving only 2 letter grades with the section info, we have no idea which student suppose those grades are assigned to. The same thing here. So between the student and the grade report, we can get student info along with grades here. Okay, then we don't know, we lost the section info. So we don't know, usually a student may take multiple classes. So with the student and the grades, without section info, it's so hard for us to identify which section or course that grade is for, you know. So that's why this on the condition that because we cross out those student and section attributes for the simplicity and redundancy purpose, remove the redundancy purpose. So that's why I think this considered not a very good design, just because when we model the grid report, like using two relationship type plus grid report, we kind of lose some information either about student info or about the section info. However, if you think about grid report has student and the section both are the anti-types also, then another thing we can do is that we can model this grid report as a relationship type instead, not anti-type. And this relationship will be between the student and section. Okay, so let me probably revise it. Okay, so we're going to refine grid report as a relationship between the section and student, and then the semantics here is very kind of clear. A student takes a section, then student will have a grade. Okay, so I call this relationship as section. I think the reason we refine this is that because grid report has both student and section, and I think student and section both are the anti-types. So that maybe give us a kind of hint that we may model grid report as a relationship between student and section. Then how do we record the grades? Recall that relationship type can always carry attributes. So that's why we can put this letter grade. Called letter grade. How about that? Okay. And then we can have another attribute called numerical grade. So here, my drawing may be a little bit awkward and ugly, but we mainly discuss the structure, not the beauty standard here. So that's fine. But after that, I think I can revise it to make it looks much neat and better. Great. Okay, so it's so hard for me to, okay, come on. I just refuse to get into, but anyway, so that's kind of the idea here. So okay, so that's kind of how we design this database. So I think initially we start grid report as the anti-type, and later we refine it to the relationship type between student and section. So make the design much simpler. So instead of having the two relationship type between student, one between student and grid report, other one between section and grid report, we can refine it into a relationship type so that we do no longer need grid report anti-type. And here the semantics here is very clear. Student takes section, then they're going to get a grade. Okay, so I think that's the hardest part for this design, to refine grid report into the relationship type. I think that's why I'm thinking the design can be an iterative process. So when you finish your first draft, you may think about if something looks a little bit awkward or maybe you miss some information when you examine the relationship anti-tabs. You may think, oh, that may be some information to missed or lost in the design. Then you can think about refine. I think ER designs mainly depend on the experience. So the more you design, I think the better you know how to handle different situation. So I think my kind of lessons is that when you think about grid report, if it has two attributes, then you know that these two attributes referring to the two different anti-tabs, then you probably think about refine that anti-tab into a relationship tab. Okay, so that is the design, the second the design ER design for the university database. So in the next class, we're going to finish this design, and then we move on to the HCAL programming. And I think also in the next class, I'm going to discuss assignment. So the assignment, ER design assignment, will be due on next Thursday. So next Tuesday, I'm going to discuss assignment so that I think you should be able to finish by due date. Okay? Any questions? Okay, if you do not have any questions, we are done for today. Thank you.